warahmatullahi wabarakatuh. My name is Muhammad Hasif bin Mahazir and my matrix number is 206444. Me and my lab partner will present you what is our project that MOD-6 synchronized counter. So what is mode counter? Mode counter are cascaded counter circuit which count to a set modulus value before resetting. The job of counter is to count by advancing the contents of the counter by one count with each clock pulse. And what is mode-6 counter? Mode-6 counter is known as divide by 6 counters, can be made by using 3 SR flip-flop. The circuit design is such that the counter counts from 0 till 5, and then the 6th count it automatically reset to begin the count again, and it consists 6 states. We are going to build a 6 mod synchronized counters using SR flip-flops. Synchronous counter in which state of the counter is equal to the count held in the circuit by the flip-flops. So this is the table for the SR flip-flop. This simple flip-flop is basically a one number memory bit stable device that has 2 inputs and 1 which will set the device, meaning the output is 1 and is labeled S, and 1 which will reset the device, meaning the output equal to 0, labeled R. So when we try to do the MOD-6 using SR flip-flop, we have designed the table, and this is the table. And now I will let Akashah, that is my lab partner, to continue this presentation. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Akashah bin Shamshuddin and my matric number is 207271. And so I will be the next presenter to explain you about our lab project. And since Hasif has explained about what is mode counter, what is MOD-6 counter all about, and also has explained about the truth table of 6 mode counter using SR flip-flop. And so for the next topic, I will explain about KMS simplification. Okay, from here, we can get S0, S1, S2, R0, R1, and also R2. And from this K-map, from this kind of map, we can get S0 equals to Q0 bar, and S1 equals to Q0 times Q1 bar times Q2 bar. And lastly is S2 equals to Q0 times Q1. And for the R, we can get from this kind of map, we can simplify it as R0 equals to Q0. And from here, R1 is equal to Q0 times Q1. And here is R2 equals to Q0 times Q2. And here is a list of our finalized of K-map simplification. So we use all of these Boolean expression, these 6 Boolean expression, to design our circuit. So for the next slide is about our design circuit. Okay, here as you can see is our design circuit. Wait a minute, I want to change the color. All right. Okay, so since S0 is equal to Q0 bar, we connect. Okay, this is the Q0 SR flip-flop, Q1 SR flip-flop, and also this is a Q2 SR flip-flop. So overall, as you can see here, there are 3 flip-flop, SR flip-flop, and 4 AND gates, and also 1 clock. And I will be talking about the first SR flip-flop. So since S0 here is equal to Q0 bar, so we connect S0 to Q0 bar, and then we connect R0, which is here, to Q0. So moving on to the next SR flip-flop, which is the second one, the Q1 SR flip-flop. Since S1 is equal to Q0 times Q1 bar times Q2 bar, as you can see here, so we connect this into the here, and so this is the Q1 bar, and we get here, which is we connect from here Q0, which because of Q0 times Q1 bar times with Q2 bar. And then for R1, which is R1 equals to Q0 times Q1, and we connect, we use a 2 input of AND gate, so Q0 with Q1. And then for the third flip-flop, third SR flip-flop, S2 is equal to Q0 times Q1, S2. So we use a 2 input AND gate. So this is a Q0, and then this is the Q1. Sorry, this is. And then for the R2, which is equal to Q0 times Q2. So R2 equals to Q0 times Q2. So we connect Q0 here, Q0 and Q2 all together. So this is our finalized design circuit. So finally, I mean, all flip-flops are clocked together because it is a synchronous counter. That's the first one, and the second one, which is it is a positive edge triggered, and the value here that we put here, the value of the counter, which is the 10 Hertz. So moving on to the next content, which is the waveform. So as you can see here, since our lab project is about MOD-6 counter, so theoretically it will reset after the 6 rises. So here, as you can see, so it is high first. So obviously after the first cycle, we'll reset here. So here is the first, second, third, fourth, fifth, and sixth. So after this line, it will reset again. So it is same as before, it will be reset. So this waveform proves that theoretically that after the 6 rises, it will reset. I think that's all from us. Thank you for watching this video and bye bye.